Good day, students. In today's class, we want to study differential equations. But before we start, there are some terms that you need to understand. So let me explain that. If you remember, when we were doing function, we wrote something like this: y is equal to f of x. And we say that this y will be the output and x is the input. So this y is depending on x. Variable y is depending on variable x. So this y is called what? Dependent variable. So that's the expected outcome. And x is called independent variable. So that means without x, y cannot stand alone. So if we now differentiate y with respect to x, we're going to have what? Dy dx. So this one is called derivative of y with respect to x. So this is the derivative or differential. This is derivative of dependent variable y with respect to independent variable x. So you can still differentiate this one again. So then you have what? D squared y dx squared. You can still differentiate again. You have the cube y dx cube, and so on and so forth. So you can go on and on and on like that. So all these ones, they are very important in differential equation. So then if you know this dy dx, if you have your dy dx, is the same thing as what? F prime of x, or we can call it what? Y prime. So in some textbooks, they write dy dx, other may write y prime. So this d square y dx squared can be written as y prime prime, while this one can be written as y prime prime, and so on like that. So you have to know all these ones. Okay, now differential equations. Differential equations are any equations involving dependent variable y, independent variable x, and what? The derivative of y with respect to x. So you can still differentiate again and again and again and again and so on like that. So now let's now define differential equations very well. So differential equations are any equations involving one or more dependent variables, one or more independent variables, and the derivatives of the dependent variables with respect to independent variables. So you may have more than one dependent variable in differential equations. You may have more than one independent variables. Then you now differentiate the dependent variables with respect to the independent variables. So here is the general form of differential equations. F of x, x here is the independent variable, y is the dependent, here is the derivative of y with respect to x. Then you differentiate it twice, differentiating it thrice, and so on and so forth. And like I explained earlier, this dy dx can be written as y prime prime, that is the square y dx squared. Then the cube y dx cube can be written as y prime and so on. So that is the definition of differential equations. involves dependent variable, independent variable, and derivative of dependent variable with respect to the independent variable. So, types of differential equations. Basically, we have two types of differential equations. We have ordinary differential equations, which can be written as ODEs, and the other one, partial differential equations, can be written as PDE. So, what do you now understand by ordinary differential equation? In ordinary differential equation, we have the dependent variable, and that dependent variable will now be derivative of dependent variable with respect to just one independent variable. Let me explain that again. In ordinary differential equation, it involves dependent variable, independent variable, and the derivative of dependent variable with just a single independent variable. So, ordinary differential equations involve dependent variable, dependent variable. It will also have what? Independent variable. And derivative of, so derivative of the dependent variable with respect to, so I want you to listen here, to a single independent variable. So that means in ordinary differential equation, the derivative can be more than one, but the dependent variable can be more than one. But the independent variable must be one, just one. So for example, may have dy dx plus 2y is equal to 0. This is ordinary differential equation. So you can see that we just have just one dependent variable and just one independent variable. So then we said that the dependent variable can be more than one. We can have du dt plus dv dt is equal to, let's say, minus 2uv. So here you can see that the dependent variable, we have two dependent variables, but just one independent variable. The dependent variables here are u and v, and the independent variable is just one. So that is how to know the ordinary differential equation. Then the ordinary differential equation will not have partial derivative. It's only ordinary, the normal derivative like this. So, but you have to have it at the back of your mind that it must only have what? A single independent variable. So, ordinary differential equation will have just one independent variable. While partial differential equations are any equations that involve dependent variables, then two or more independent variables. Here, the independent variables are more than one. more than one independent variables. And the partial, so take note, partial derivative of dependent variables with respect to two or more independent variables. Take note, here we have more than one independent variables for partial differential equation. Then it also has a partial derivative of the dependent variables with respect to more than two or more independent variables. So this is not ordinary derivative but partial. And how do we write that? You write it like this. That is the partial derivative. Then if you take note, you can see that you have two dependent variables, u and v, and we have two independent variables here also. So you must have more than one independent variable for partial derivative. Then look at this one also, example 2. So we have die square u over die t squared plus die square v die y squared plus die w die z is equal to 0. So here you can have as many as dependent variables, then partial derivative of that dependent variables with respect to more than one independent variables. So unlike ordinary differential equation will not have partial derivative and it must have just one independent variable. But for partial differential equation, it can have more than one dependent variables and the independent variable must be more than one, two or more independent variables, and it should have partial derivative, not ordinary differential derivative. So examples of differential equations. So we know that differential equation involves independent variable, dependent variable, and derivative of the dependent variable with respect to independent variable. So here is an example of differential equation. So then here also the square y, the x squared plus y, which is dependent, the derivative of dependent with respect to independent plus square of the independent variable. So it's also a differential equation. Then die u die x plus die v die y plus die w die v is also differential equation, but this one is partial differential equation. These number 1 and 2, they are ordinary differential equations. Then number 4, die u die t die plus die square u over die x cubed plus die square v die y squared is also a differential equation. So it's also partial differential equation. So here has the exercises that we do now, exercise that you are going to do. Determine the type of each of the following differential equations. So number 1 to 5. So I'm going to leave the answer after this one, but just make sure you try that one. So till we meet again, bye bye.